If I could only eat candy, would I only eat candy? I would probably eat candy canes. Hey, so we're looking at the sixth example of electric potentials. What we have here are 2-point charges separated by 35 centimeters. One of the charges is 5 nanocoulombs, and it's positive, so there's 5, and that's nano, so that's times 10 to the minus 9. And then the other charge is minus 3 nanocoulombs, so minus 3 times 10 to the minus 9. That's a bad 3. We'll redo that 3. So times 10 to the minus 9. Now, what we would like to know is what is the potential difference between a point infinitely far away, so out at infinity, and at a point midway between the charges right here, okay? And as we know, this distance here was 0.35 meters, that's 35 centimeters. So halfway of that is whatever 35 divided by 2 is, okay? So how do we go about solving this problem? Well, the nice thing about this problem here is that we're looking at potentials, which are scalars. And what this means is that if I have 2 charges here, positive and negative, 1 and 2, I can find the total voltage just by summing up each of their voltages there. So the sum of the voltage, or the total voltage, is just equal to the voltage from the 5 nanocoulombs plus the voltage from the negative 3 nanocoulombs. I just add them together. And all I need to do is find the voltage at that point. Now, the other thing to keep in mind and remember is when we talk about voltages, they are potential differences. So we're comparing that voltage to something else. And if we think about our first initial examples, we were saying, like, look, we have 2 parallel plates. This one is at positive 10. This one is at positive 2. So that means the potential across them is 8 volts, okay? Because there's an 8-volt drop there. Now, what we'll do for our point charges is we will say out at infinity, there is a potential of 0. So we're always comparing whatever potential we get from these to 0. So to find the voltage due to the 5 nanocoulombs at this center point right here, we just need to run the voltage equation, which is just, for a point charge, KQ over R. And then that's going to be minus 0, because it's the final position minus the initial. And that initial position is at infinity, which means that R is infinite, which means this is effectively 0 in that case. So this is all we need to do for both charges here, and then add them up. So let's go ahead and do this. We know that K is 9 times 10 to the 9th. That's Coulomb's constant. Our Q's here are going to be 5 times 10 to the minus 9th for the first charge, and then negative 3 times 10 to the minus 9th for the second. We will include the negative because these are potentials and they're scalars, so we need that. So for the first one, 5 times 10 to the minus 9. Whoa, what is going on there? And then we'll divide that by R, which is 0.35 divided by 2, whatever that is, 0.175, okay? And if we pull our calculator, which is way over there, if we throw our calculator down on this, we'll find that we get a positive number here, because all these are positive, and we get about 257 volts out of that, okay? If we do this for the negative charge here, it's the same idea, but we have Coulomb's constant, 9 times 10 to the 9th. The charge now is negative 3 times 10 to the minus 9th, divided by the same distance, 0.35 over 2, because it's that halfway point. And when we do this, we get a negative number. We're going to get negative 15 volts. Okay? So that's what we get for our second one. Oops, did I say 15? I meant, bad reading. Negative 154 volts. Woof. Okay, so these are our 2 voltages here. To sum the voltages, we simply add them together. So 257 minus 154, or adding the negative 154, will give us a value of about 103 volts right there. Okay, if we wanted to play with sig figs, we could say that, this is technically 100, and that is a significant figure right there, but whatever, who cares? What matters is that this is the voltage as given by those 2 point charges at some point in between them, directly in between them right here. This point is compared to an infinite distance away, which is 0. So that 103, or 100 if you're using sig figs and whatnot, that's the answer. That's it. When you compare to something an infinite distance away, you're comparing it to the reference position of a 0 voltage. So that's our answer right there. That's it. It's finished. All we had to do was find each of the individual voltages and add them up. Super easy, super straightforward. I love it. So that's how you do this problem. We'll see some more, 2 more voltage problems coming up right after this. But until then, take it easy.